بسم الله الرحمن الرحيم. اللهم افتح علينا نعمتك وانشر علينا من خزائن رحمتك يا أرحم الراحمين. ربي اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي. ربي يسر ولا تعسر، ربي تمم بالخير. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. صلى الله على سيدنا محمد وعلى آله وصحبه وسلم. والحمد لله رب العالمين. آمين.
Right. So last time we stopped at spectroscopy, right? So only a little bit, if I'm not mistaken. Am I right?
Yes.
Yes, madam.
Okay. Let me see. Where's the notes just now? Okay. So saya akan share screen. Boleh nampak ke my screen?
Boleh.
Alright. Okay. So yang mana? Bukan ke dah habis ke? Because we had discussed on the what does it mean by the atomic transition until the molecular transition. Kan? And then it's supposed to be we shall start on the new what we call the new chapter, is it? Okay, never mind. So let me explain first. Okay. In our previous class, we had learned on the different method of method of interactions in the spectroscopy. So it involved the absorption process, whereby the EMR is absorbed by an atom, molecule, or ion, taking it to a higher energy state. Okay, and then another interaction that might exist when the light or the what we call the EMR, magnetic radiation, dikenakan kepada kita punya sampel, okay, which is emission. Okay, so emission ni the release of photon by an atom. Okay, katakanlah kalau absorb, atom, molekul atau ion itu dia akan absorb. Okay, speaking of the emission, okay, so maksudnya previously you had discussed in a group that the absorption process happened from the ground state to the excitation state. That is what we call the absorption process. But then sometimes from the excitation state, okay, dia berlakunya what we call the emission process, whereby the release of the photon. Okay, so as you can see here, these are the absorption process. Okay, from the lower ground state to the higher state, which is what we call the excitation state lah. Okay, so another type of interactions that might exist in a spectroscopy, which is what we call the scattering. Okay, so this scattering or reflection, okay, and excitation to a visual state lower in energy. Scattering ni bila dia punya electronic transition dia tu energy state, the visual state dia tu lower as compared to the real electronic transition. Alright, So as you had learned previously, the absorption process might exist at the molecular or atomic lah. Okay, so as I mentioned in the last class, okay, for example, the absorption process ni bila dia berlaku absorption, what kind of absorption yang berlaku? Adakah dia at molecular level or at atomic level? Okay, kalau molecular level dia melibatkan bonding yang ada. Okay, kalau atomic ni dia dekat every single atom tersebut lah. So as you can see at the molecular level, kita akan ada interaction between molecule. Atom A, atom B tu bila dicampur dia akan jadi molekul kan. So what are the electronic transition that might exist lah. So this absorption process of the electronic transition for the absorption process ni actually dia depends on, katakanlah kalau UV-Vis dia absorption process, so dia melibatkan molecular level as well as atomic. Tetapi katakanlah kalau FTIR, okay, infrared, dia juga melibatkan absorption process tetapi dia berlaku rotational ataupun vibration dekat dia punya molekul. Okay, so ini adalah contoh untuk absorption lah. Absorption from the lower state to the lower state or the ground state to the higher state. Okay, so that is what we call the absorption process. Okay, there are three main process of the absorption. Absorption of radiation leads to a higher rotational energy level in a rotational transition. Okay, maksud dia di sini ialah absorption radiation tu dia memberikan higher punya energy level. Okay, and secondly, a vibrational transition which occur on absorption of quantized energy. This lead to an increased vibrational. So sama ada dia berlaku proses rotation ataupun vibrational. Dia vibrate, dia bergetar dengan ataupun dia rotate. Okay, and then electronic transition electron of the molecule being raised to a higher electron. Okay, so inilah yang dikatakan the absorption process actually the absorption process is a radiation is absorbed by an atom, taking it to a higher energy state. Kalau emission to the lower energy state. Kalau scattering, dia punya energy dia tu mungkin petala 1, 2, which is lower than its real electronic transition. Alright, so hopefully you all boleh faham lah. Boleh faham ke? Any question then from the floor?
Madam.
Alright, so let's say lah the energy actually the absorption of the spectroscopy, the energy level that might exist, dia ada ordering dia. Okay, energy level can be rated lah. Katakanlah kalau absorption process itu berlaku at the electronic transition, okay, which is greater than the vibration, and then vibration is greater than rotational. Meaning that kalau infrared rotation dia berlaku rotation, so infrared ni dia lebih rendah dia punya absorption process dia, energy levels which is lower as compared to the UV-Vis. Okay, so this each of this transition actually dia berbeza lah. Okay, so our order dia electronic transition, and then the biggest or the highest, followed by the vibrational, and finally the rotational. Okay, so the rotational energy at lower energy, longer wavelength, and this energy actually is insufficient lah. But then ini yang kita guna dia in the infrared as well as the UV punya region. Alright, okay, these are the energy level. Okay, so as you can see here, A, okay, mana dia nak zoom. Okay, so A, which is what we call the rotational transition. So dia punya transition dia tu lower, the energy is lower compared to the vibration, and then vibration electronic transition is the highest lah. Okay, at the atomic level okay. Okay, and then the emissions of the EMR, okay, atoms, molecule and ions, it can be excited. Okay, so bila dia orang, when it is in the relaxed state, okay, they release the excess energy. Okay, so itulah bila cahaya tu, EMR tu kena pada our sample, So what happen is sampel yang berbeza memberikan memberikan interaction yang berbeza. Okay, so speaking of the emission, inilah, so emission ni selalunya dia berbeza from the absorption, whereby from the ground state, okay, to the from the excited state to the ground state, and during the process dia akan release the photon. Okay, so this is what we call the emission of the EMR. Okay, so macam mana kalau kita nak tengok there are different type of the spectroscopy which is memberikan different interaction. Okay, so as you can see, gamma at the nuclear, okay, gamma, X-ray selalunya this goes for the emission lah. Okay, and then kalau UV absorption, normally the bonding electron. Kalau UV vis pun sama, bonding electron. Kalau IR and Raman spectroscopy, dia menggunakan rotation atau vibration of the molecules. Okay, contohnya katakanlah kita ada sampel macam epoxy resin plus glass fiber. Okay, so katakanlah bila you conduct the UV vis, okay, bila you buat UV vis, the EMR radiation related which is UV and visible light, okay, dia akan attack transition that happen is the bonding of the electron yang ada dalam epoxy dengan glass fiber. Tetapi kalau IR, dia pun akan lalukan cahaya kepada our sample, tetapi dia instead of dia mengira bonding electron, tetapi dia measure rotation or vibration of the molecule. Katakanlah C double bond C, vibrationnya adalah scattering ataupun wiggle. Okay, so dia berbeza-beza. Alright, so maksudnya untuk satu-satu sampel, we can conduct different type of the spectroscopy, okay, to determine what material presence in our sample. But then cara setiap instrumen itu mengukur berbeza-beza, okay, berbeza-beza mengikut dia punya EMR lah. Okay, kalau UV vis more on the bonding electron, kalau IR rotation or vibration of the molecule. Okay, so later on when we progressing to the UV vis as well as IR, then kita akan tahulah, you all akan nampak sebenarnya what type of electronic transition that might exist between those instrument. Alright. Okay, so kita dah selesai yang ni. Mungkin kita tengok sikit kot, mungkin a little bit introduction on the what we call next chapter, which is so we move on to the chapter 6, UV UV visible. Okay lah, so mungkin kita a little bit introduction or ta'aruf with the UV visible. Okay, so in this chapter, you are going to learn on mana dia? Mana dia? Kenapa blank? Tak boleh buat slideshow lah. Okay, so in this chapter, you are going to learn the molecular absorption. Okay, absorption and electronic energy transition and different type of the electronic transition, which is you will be exposed on the pi to pi star, okay, sigma to sigma star. Okay, what does it mean by that lah? Dia punya absorption process dia tu, kalau kita kecilkan dia ataupun kita buka lagi, okay, absorption process tu dia berlakunya different type of the electronic transition. Okay, dekat kita punya dia punya bonding Okay, and the third one, the specific absorption pattern and some sample structure, conjugated diene and carbonyls, Woodward and Fischer rule. Okay, number 5 you will be exposed on the calculation. Macam mana kita nak predict the lambda length, okay, the wave the lambda for any component or molecule by using the Woodward Fischer rule. So this is one of my favorite topic because dia ada calculation lah, so tak adalah macam bosan sangat. And then a little bit on the quantitative analysis, Beers-Lambert law, concentration determination, little bit on the instrumentation is a must have. Okay, application as well as the polymer samples. Okay, so these polymer samples actually we are going to discuss let's say lah bila kita dapat UV vis tu, how we are going to discuss the spectrum that we obtain from the UV visible. Alright. Okay, so basically apa yang dimaksudkan dengan UV visible? So previously you had learned on the spectroscopy. So UV visible fall under the spectroscopy. Okay, so sama sahaja. Speaking of spectroscopy, it is an interaction between a method of interaction between light and our sample. Okay, itu je yang you all first thing that you have to understand. Okay, dia mesti kena ada light source dia. Okay, so these are the UV visible whereby we have the light source. Kita hanya ada dua sahaja light source. Now, number one which is what we call the UV punya light. Okay, another one which is visible light. Okay, it only involve these two region. Okay, and yes, we're gonna have the diffraction ataupun prism grating punya prism. And then aperture, normally aperture ni kita nak memastikan dia punya cahaya yang masuk kepada sampel tu selari. Dia tak ada macam berlaku pecahan cahaya yang terlalu berserk It's supposed to be kita akan convertkan from the diffraction grating punya light tu supaya cahaya yang kena tu adalah cahaya yang consistent. Alright, and then we're going to have our sample cuvette lah. So if you still remember last time during your diploma, okay, you have a 1 centimeter times 1 centimeter of the cuvette which is made from the plastic or glass. Must made from a crystal clear material. If not, kalaulah dia buat dia punya cuvette dia tu gelap, memang this light cannot be penetrable. Okay, so bila dia tak boleh nak penetrate, so of course lah dia tak boleh nak detect lah. Okay, what kind of bonding that might exist in the UV visible. Okay, so here is the theory the theory of the principle of the UV. Okay, so UV visible ni kita ada the range of wavelength. Okay, UV bermula daripada 200 okay, 200 ke 400 itu adalah UV punya region. And then yang color warna biru, and then yang color visible light tu, you can see visible light is we have all those 7 colors lah. Okay, dia memang ada banyak color, dia ada primary color dia which is blue, green, yellow, red. Okay, so as you can see the visible region start from 400 to 800. Okay, so ini yang disebut sebagai UV visible. So it started as low as 200 okay, to 400 whereby corresponding to the UV region, and 400 to 800 nanometer actually referring to the visible region. Alright. Okay, so the theory or principle of the UV. So kalau tadi kita dah tengok kita on the spectroscopy chapter, okay, kita dah tengok dah bila light kena pada kita punya sample, what happen is dia akan berlaku interaction, sama ada dia berlaku proses emission, absorption ataupun scattering. Okay, so what are the main what are the main principle of the UV visible ni? Okay, adakah dia berlaku proses absorption ke, scattering ke ataupun emission? Anyone can answer me? Ada ke yang boleh bantu?
Absorption.
Yeah, so basically for the UV visible, we lots of absorption happens lah. Okay, so berlakunya electronic transition. Bila light tu kena, so dia ada berlaku changes in the molecule lah. Okay, so as you can see the same thing, speaking of the absorption from the ground state to the excited state. Okay, so this molecular electronic transition take place when electron in a molecule are excited from one energy level to a higher energy level. Okay, so kita ada different level kita ada N1, N2, N3. Okay, depends on kita punya elektron. Betul, susunan elektron kita. So what happen here is dia mungkin boleh naik daripada ground state to the satu state yang tinggi je daripada dia. Okay, atau mungkin juga dia boleh naik 3 state, 3 petala selepas tu. Okay, so that depends on you punya what kind of bonding that you have lah. Okay, so the theory which is electron jump from the lower to a higher ones lah. Okay, from the ground state to the higher state, and then during this process, bila electron tu jumps, okay, from lower level to a higher level, energy is being absorbed. Okay, katakanlah kalau dia release the energy, kalau dia release the photon, itu kita panggil dia apa dia? Absorption ke, emission ke, scattering? We call it emissions. Okay, bila dia release kan photon. Okay, so this method normally used in the UV visible spectroscopy and AAS, atomic absorption spectroscopy. Alright. Okay, so these are the theory or the working principle. Okay, in UV visible berlakunya electronic transition. Electron tu dia boleh jump, okay, from the lower state to the higher state. So the electronic transition that take place in visible and ultraviolet regions of the substance are due to the absorption. Okay, so betul lah macam yang kawan juga cakap tadi, Idina jawab tu. Okay, memang this due to the absorption of radiation by specific types of groups. Okay, katakanlah dia merupakan C double bond C. So dia punya absorption dia takkan sama dengan C single bond C. Okay, katakanlah dia C double bond O, dia punya absorption dia tu takkan sama dengan CH. Okay, so bila light kena dekat kita punya material, dan kita kena faham our compound tu dia terdiri daripada different type of bonding. Ada yang single bond, ada yang double bond, ada yang C double bond O. So bila dia kena, dia memberikan electronic transition yang berbeza. So bila electronic transition tu berbeza, itu yang boleh kita kita kenal pasti. Okay, kita kenal pasti what kind of bond ataupun what kind of functional group that might present in our sample. Okay, contohnya absorption of radiation by specific type of groups, bonds and functional group within the molecule. Okay, so kita punya molekul tu adalah absorbing punya species lah. So this wavelength of radiation and the intensity amount of the photon being absorbed are dependent on the type of electronic transition. So basically ada 3 jenis electronic transition that involved in the UV visible, which is pi, sigma dengan n lah. Okay, elektron. Okay, so yang ni saya rasa saya nak you all baca dulu. Okay, the theory of principle of the UV, sebab macam pagi ni kita just masuk sikit dulu pasal UV vis. Okay, so that nanti you all baca the theory of the principle of the UV lah. So kalau kita tengok dia ada HOMO, which is highest occupied molecular orbital to the lowest unoccupied molecular orbital. HOMO tu LOMO lah. Okay, so dia inilah kita ada 3 jenis electronic transition yang mungkin berlaku. And then kalau you all tengok selalunya kalau sigma to pi tu kita panggil dia as a occupied punya petala orbital, and then pi star dengan sigma star tu unoccupied, and then kita tengok dia punya energy level dia tu berbeza-beza. So dia mungkin boleh lompat from sigma to pi. Dia mungkin boleh lompat from sigma to pi star. Okay, bergantung kepada what kind of molecule yang dia ada. Adakah dia having a C double bond O punya molekul ataupun C double bond C ke punya molekul lah. Okay. Nanti next class saya akan explain lah pasal ni. Okay, sebabnya yang ni kalau saya dia macam agak panjang jugalah. Okay, so saya nak you all baca dulu nota yang ni, and then later on barulah kita tengoklah kita tengok what does it mean by the pi to pi star. So sebabnya sekejap saya tengok. Yang ni bila kita start dengan this other process. Okay. Okay, so kalau inilah yang saya cakap tadi. Okay, katakanlah dia punya electronic transition tu from the electron, what we call the occupied punya to the unoccupied punya orbital. Okay, so dia punya energy dia tu lower. Okay, compare tu kalau lah from the sigma to pi star ataupun sigma to sigma star, dia punya energy level dia lagi tinggi. Okay, so based on this different electronic transition ataupun energy level, itu yang kita boleh membezakan. Okay, so kalau pi tu sigma to sigma star, so ini biasanya berlaku dalam alkenes. Okay, CH. Okay, katakanlah kalau sigma to pi star, ini normally berlaku in carbonyl compound C double bond O. Okay, katakanlah pi to pi star in alkenes, okay, carbonyl group, alkynes and so on lah. Okay, kalau N to sigma, dia berlaku dengan kehadiran oksigen, nitrogen, sulfur, klorin bila dia ada halogen punya compound. Okay, so you can see that the electronic transition ni actually dia dah ada specific punya bonding. So that's why bila kita check epoxy resin, definitely you gonna have what we call dia akan ada dia akan ada macam kalau epoxy resin dia akan ada C double bond O, dia akan ada CH. Okay, so dia punya electronic transition untuk epoxy resin tu mungkin berlaku dekat sigma to sigma star, okay, ataupun sigma to pi star. So that depends. So nanti kita akan tengok yang ni. Saya nak you all baca dulu, try to digest on your own, so that nanti bila saya explain you all akan lebih faham lah. Okay, so ini kita panggil LOMO what we call, mana dia? Mana dia? Okay. Kalau kita tengok yang bawah tu, yang tak ada star tu kita panggil dia occupied punya orbital, which is what we call the highest occupied molecular orbital HOMO. Okay, and then yang atas tu which is unoccupied molecular orbital LUMO. So untuk HOMO kita ada 3. Okay, sigma, pi dengan elektron, and then untuk LUMO kita ada 2 lah, pi star dengan sigma star. Okay, dia tak ada n star. Okay, sebab n tu dia macam intermediate between this occupied dengan unoccupied punya orbital lah. Alright. Okay, so ada soalan tak so far? Okay, so saya nak you all baca dulu. Contohnya dekat sini pun dia dah bagi tahu kalau n to pi, pi to pi transition, dia berada dekat wavelength mana, berapa nanometer biasanya berlaku. So that's why kalau you still remember last time bila you all conduct UVs dekat lab, okay, so you akan dapat contohnya you akan dapat something like this, right? Okay. You all akan dapat something like this. Okay, so apa yang dimaksudkan dengan lambda max 222 nanometer? Okay, so kalau kita tengok region mana actually 222 ni berada. Okay, so kalau kita tengok 222 ni to 700, so it might dia mungkin mempunyai kita boleh kata dia mempunyai electronic transition between n to pi star and pi to pi star, between 200 to 700 nanometer. Alright, so biasanya kita memang boleh differentiate okay, contohnya kalau macam this molecule isoprene, so the lambda maximum which is 222 nanometer. Tetapi katakanlah untuk epoxy resin ataupun untuk some other different material, dia mungkin berbeza-beza. And if I'm not mistaken, untuk KMNO4, last time when you during your diploma time, okay, when you conduct the UV vis, dia punya tu 250 nanometer. Okay, so maksudnya dia menunjukkan region yang berbeza-beza untuk different compound. You all boleh faham ke? Okay, kalau tak faham, baca dulu, nanti saya akan explain this principle lah, macam mana dia punya transition tu berlaku. Okay, so apa yang you all kena faham, bila light kena dekat kita punya material, inilah electronic transition, elektron dalam kita punya molekul ataupun compound, dia akan bergerak. Okay, dia akan move to the higher state or mungkin dia akan move to the lower state. Okay, bergantung dengan what kind of electronic transition, what kind of bonding yang dia ada, itu yang membuatkan dia kita boleh baca dia lah using this UV visible. Tetapi region yang dia boleh baca hanyalah between 200 and 800 nanometer. Okay, sebelum 200 dan selepas 800 dia tak boleh baca. Okay, cuma kalau kita tengok kebanyakan mana dia, sigma to sigma. Okay, so kebanyakan compound memang falls under 200 to 800. Okay, contohnya macam in alkanes, carbonyl compound, okay, semua ni fall, dia ada wave number dia yang tersendiri. Okay, so sebenarnya apa yang dimaksudkan dengan tapi later on kita akan tengoklah mana ya. Okay, so apa yang dimaksudkan dengan lambda max? So lambda max tu kita ambil dia when the maximum absorbance lah, yang sebelah kiri ni adalah absorbance so yang ni adalah kita punya lambda lah. Okay, so yang mana dia punya absorbance yang paling tinggi itu yang kita ambil. So sebenarnya isoprene ni dia memang ada dia punya compound daripada 210 hingga 240 ataupun sehingga 235. Tetapi dia punya lambda max dia yang mana absorption paling tinggi was found at 222 nanometer. Okay, macam itulah. Okay, so saya rasa you all baca dulu, nanti kita akan saya akan explain lah, and then nanti saya akan share dengan you all. Actually we have quite a number of okay, pengiraan Woodward Fisher rules ni selalunya kalau Woodward Fisher rules ni kita akan ambil 2 jam punya slot, sebab Woodward Fisher rules ni dia ada different type of dia ada 3 jenis macam mana kita nak calculate. Katakanlah dia adalah benzoil, okay, dia ada benzene ring, so calculation dia berbeza, dia punya rules ataupun law dia. Katakanlah kalau dia conjugated diene, dia berbeza cara kita nak mengira dia. Okay, so nanti mungkin saya akan skip yang bahagian Woodward Fisher rules. So Woodward Fisher rules ni memang saya akan ambil on kita akan buat on Tuesday lah. Okay, maybe ni work week 4, 5, work week 6 macam tu kot. Okay, and then ni saya just nak tunjuk dengan you all. ini adalah absorption maximum lambda max bagi setengah compound lah. Okay, so sebenarnya bila kita run ataupun kita conduct UV vis, we should be able to determine its maximum lambda ataupun lambda max. Okay, anyhow, kita boleh predict. Katakanlah dia bagi you macam ni. Okay, satu molekul punya compound. So by using the Woodward-Fisher rules, you should be able to predict berapa dia punya lambda max dia. Okay, so saya suka calculate tu, cuma ada parts yang agak confused. So first thing first, kita kena determine what type of compound is it. Is it benzil ataupun conjugated diene. Okay, so kalau you all betul-betul faham Woodward-Fisher rules, memang everything will be at your fingertips lah. Okay, and ini pun adalah contoh ini adalah contoh spektrum, okay, untuk hexane solution So bila dia in vapor state, so dia berbeza berbanding dengan hexane punya solution lah, ataupun bila dia ada aqueous punya solution. Okay, and then nanti you all akan tengok these are some examples on the inorganic ions punya ni lah, inorganic ions punya spektrum. Okay, so saya rasa kita berhenti sampai sini. Nanti kita akan belajar jugalah chromophores ni. Okay, chromophores ni adalah komponen yang dia boleh absorb colours lah. Okay, so nanti kita akan tengok, and then ada little bit exercise on the Beers-Lambert law lah. Okay, so saya rasa itu sahaja. Ada soalan tak from the floor? Okay, so kalau tak ada, kita berhenti di sini, and then let me check how many of you are present here. Apa ni? Macam nak kira. There are 25 of you, right? So supposedly kita ada 26, 27, right? Termasuk Faris kan? So ada yang tak mai ke? Okay, never mind. Nanti during the class saya minta you all tanda kedatangan So ada saya pun tak pasti, tapi Faris tak mai kot saya rasa ni. Ada ke? Macam tak ada Saya rasa macam dia ada kan dalam grup 596 kan? Kan? Faris ada kan dalam grup 596? Hello?
Ada.
Ada kan? Faris
ada.
is not here. Tak apalah. Okay, so anyhow, thank you so much. So 96% or 98% students are here lah. So thank you so much, and then you should enjoy your long weekend. Your long weekend lah. Alright, so thank